Okay, so in this lesson, we're going to talk about transformations on the coordinate plane. So if you have a coordinate plane, right? Sometimes we call those axes or a coordinate plane. Transformations are just different types of movement that takes place, okay, on the coordinate plane. It can be moving a shape or it can be moving a function. Okay, so we're going to talk about today we're going to look at a bunch of different shapes and moving those around, and then eventually you'll be learning about moving different functions around on the coordinate plane. So in your packet that the sub gave you, there on the first page, you have this table. So what we're going to do is we're going to talk through the 4 different types of transformations that are possible in mathematics. So we're going to talk about these 4 different types, and then we're going to do a little quick sketch of them. So let me show you first a translation. And oftentimes we call a translation a slide or a shift. Okay, and this can be horizontal or it can be vertical. Right, so it can be going side to side or it can be going up or down. Okay, and I'll show you what a translation actually looks like. So if you have a blue object and you have an image, this is what we call a horizontal translation. So as you see, it's moving side to side. This is called a horizontal translation of the shape. You can also have a vertical translation. So now the shape is being moved up or down. Right, so this would be only a vertical translation. And then this would be vertical and then horizontal. Okay, so you can see that translations you can have vertical or horizontal, or you can have both. Okay, so then on your own, just go ahead and sketch a sort of a picture of what that could look like. The next one is a rotation. So a rotation, usually you're rotating around a certain point. Okay, so you're going to be turning, it's turning an object or a function about a specific point. And when you first learn these things, like we're learning right now, usually you're just turning about the origin. Okay, so the origin is here, and we're just turning it about the origin. So we're turning it around the origin. So what you can see is it's being turned around the origin. And so that's what you're going to be doing today as well. So these are clockwise rotations. And do you see how the degrees are changing here? So often you can have, right, if I want to rotate it 90 degrees, it's going to look like, oh, it's difficult to get to 90, but you get the point. If I want to rotate it 180 degrees, I rotate it a full half circle. So it's going to go a half circle all the way on the other side. Okay, so those are rotations, and we measure rotations in degrees. So you can write something about degrees here as well. You measure this with degrees. And then go ahead and sketch a picture here as well. If you need to pause the video, you can. Okay, and now a reflection. So a reflection is similar like to a mirror, right? You have some object in blue, and it's being reflected across a certain line. Okay, so on your notes, make sure that you write it's a mirror or a flip. Okay, some teachers will call it mirror, some teachers call it flip, and it's over a certain line. So we learned about different lines. So the name of this line would be x equals 1. Right? So we see this line at x equals 1. So this is a reflection over the line x equals 1. Yeah, see a reflection over the line x equals 1. So of course you can change this line too. We could turn the line, right, so that it goes this way. And that's the reflection over the line at y equals 0. Yeah, and so now it's reflecting over whichever line we choose. Okay, and I think I can also enlarge the object. Oh no, I'm not able to do that. Yeah, so we can see it's just a mirror image. So go ahead and sketch a reflection here as well. And then a dilation is something, we're not going to actually practice a dilation today, but I will give you the definition so you know what it is. A dilation is a stretch or an enlargement. So, oops, right? A stretch or making it bigger. So there are a lot of different names for this. So I'll show you what that looks like. Of course, here it says enlargement. So if I have a shape and I want to enlarge it by 2 times, this has a scale factor of 2. But maybe I'll enlarge it by 2.5 or 3 times or 1.5 times, right? So I'm enlarging it by a certain number as well. So this is what we call a stretch or an enlargement, a dilation. But there's another type when it gets smaller. So do you see how I just shrunk it in half? And that's another type of dilation that we call a shrink or a compression. Okay, so this is a shrink or a compression. Right, I've shrunk it by 0.5. You can also shrink it by 0.25 or 0.01. You can shrink it in any different way that you want. But always we shrink something by a scale factor. That's what we say. So by a scale factor. And you can go ahead and make a sketch here as well. And now I'm just going to do, in your packet, you've got 3 pages. So we're going to do some translations, rotations, and reflections of different shapes. I am going to show you a few. I'm just going to give you the first one of each of those practice problems. Okay, so let's look at first page, which is translation. Now this whole shape needs to be translated 5 units down, 4 units right. So 5 units down, 1, 2, 3, 4, 5, 4 units right. And it goes over 3. From there up 2, and I'm just going to redraw the shape. And this has gone through both a vertical shift and a horizontal shift. Okay, so it has both horizontal and vertical translation. For the first one on the rotation, so we're going to rotate this object by 180 degrees about the origin. So the origin, of course, is here. We call that the origin. And we need to rotate it a full 180 degrees. So I'll redraw it like this, and it's just basically going to flip itself around. And it will look something like that, right? So it's rotated a full 180 degrees. And we know 180 degrees is a straight line, right? So that's how we know how far to rotate it. And then the last one I want to walk you through is just a reflection. So a reflection across the line, x equals 4. Well, first we need to actually draw the line x equals 4. Okay, so x equals 4 is right here. Right? And so this is just a mirror image drawn. So it's over 1, 2. So I'm going to go 1, 2 this way. That's where it's going to start. And then it goes from there, it goes over 3. So over 3, oops, over 3. And then it goes in 1, over 3, in 1. Yeah. Okay, so that's a reflection across the line, x equals 4. Notice that this this could be different if the line that it's being reflected across is different. Okay, so go ahead and practice that today. Please remember that this is not in any way related to the task. Math classes 1 and 2, you've already had your preparation for the task. And on Monday, math 3, 4, and 5, you will get your preparation for the task. So please remember that this isn't going to be on the task at all, but it is just some practice for for some things we're going to do throughout this unit. Okay, have a great day. See you guys on Monday or Tuesday.